Good morning, good afternoon, or good evening, depending on when you're watching this. Now we're going to look today at maximum and minimum values, and we want to find the maximum and the minimum value of a function of the form f of x is equal to a cos x plus b sin x. Now if you were asked to do that, you would have to express it as a single trig function. Right at the outset, we said expressions like a cos x plus b sin x occur frequently in applied maths, and it's very useful to be able to express it as a single trig function. Well, here's one of the reasons why. If we take the combination of cosine and sine and express it as a single trig function, then we can look at finding a maximum and a minimum value. Now let's look at that by looking at this example. Find the maximum and minimum values of f of x is equal to 6 cos x plus 8 sin x. Now that's the way it can appear in an exam question. There is no instruction to you that you need to take that and express it as a single trig function in this question. You have to know that in order to find a maximum or a minimum value of a function of that sort, you require to express it as a single trig function. Sometimes the question leads you into it, but often it's as stark as that question. Find the maximum and minimum value of 6 cos x plus 8 sin x. There is no suggestion that you have to take it and express it as a single trig function. That's for you to realise that that's what you have to do. So find the maximum and minimum values of f of x equals 6 cos x plus 8 sin x, and find the values of x in the domain from 0 to 360 degrees for which these maximum and minimum values occur. So we start in exactly the same way. You realise I have to express it as a single trig function. Now, we have looked at expressing it as a single trig function as k cos x minus alpha, k cos x plus alpha, k sin x minus alpha, k sin x plus alpha, and it really doesn't matter which one of those you use, as long as you realise you have to express it as a single trig function. However, it's often easier to use k cos x minus alpha. So that should be your go-to function in this case. So I'm going to start with 6 cos x plus 8 sin x equals k cos x minus alpha, realising I need it as a single trig function. So that's something that's old hat to you by now. You've done so many of them. We'll go through it very quickly. You have to use your expansion. That's absolutely essential. You have to identify, underline your cos x, pick out your coefficient. So we've done all of that there, and we've worked out that k is equal to 10. We found alpha in exactly the same manner, k sin alpha over k cos alpha. We've noted that the sine, cosine, tan are all positive. It's in the first quadrant. So once you make that equal to k cos x minus alpha, that should be very easy to you. You've done lots of them. Okay, so we've got that. Let's look at what we have now and really what today's problem is. So we have taken that and we have expressed it as 6 cos x plus 8 sin x equals k cos x minus alpha has become 6 cos x plus 8 sin x equals 10 cos x minus 53.1. Now we were asked to find the maximum and the minimum. That is our problem here. Find the maximum and the minimum. So find the maximum and minimum value of 10 cos x minus 53.1. So our first stage was to write it as k cos x minus alpha, and we've done that. So this is 10 times the cosine of an angle. And 10 is a constant. The only thing that changes, the variable here, is the value of cos x minus 53.1. 10 times the cosine of some angle. Now I've sketched the cosine graph here, which you should be very familiar with, and let's look at when it has its maximum value we know is 1, its minimum value is -1. So if we were asked what is the maximum that this can be, it would be 10 times the maximum value of the cosine of an angle. So it's 10 times 1, that would be the maximum value. So the maximum value is 10 times 1 is equal to 10. Now when would that occur? When is the cosine at a maximum? Well, the cosine of 0 is equal to 1 and the cosine of 360 is equal to 1. So this x minus 53.1, that would have to be the cosine of 0 or the cosine of 360. So that x minus 53.1 would have to be 0. And if we solve that equation, x would have to be 53.1. Now the other alternative is a cosine of 360, but that's not an option here. And the reason is that this would be cos 360. So if we had x minus 53.1 is equal to 360, then that would be equal to 360 plus 53.1. And that is outside the stated domain. The domain was between 0 and 360, so we are not interested in that. This is our value. X is equal to 53.1. So the maximum value, 10 times 1. When does the cosine have a maximum? Maximum is cosine of 0. So x minus 53.1 would have to be 0. X would be 53.1. So the maximum value is 10, and that occurs when x is equal to 53.1. Now the minimum value, what is the minimum value that the cosine can take? The minimum value the cosine can take is negative 1. So the minimum value would be 10 times negative 1 is equal to negative 10. So minimum value will be negative 10, and that will happen where the cosine of what angle gives me a minimum? The cosine of 180 is equal to negative 1. So that would have to be 10 times the cosine of 180. So x minus 53.1 would have to be equal to 180. So x would be 180 plus 53.1, 233.1. So minimum, negative 10, when x is equal to 233.1. Thank you.